What's up everyone, Patrick here, welcome back. Moving on to the next question. This one's going to be fairly unique, a little bit tricky, so we have to find the area of this shaded region over here as an exact value. So it can't be in decimals. And before getting into the algebra, I just want to describe what's going on here. So notice that we have a circle over here, and we have intercepts 8 and 0, 0 and 8. So notice it's a circle that is centered at 0 and 0 and has a radius of 8. And then also notice that we have these two lines over here. So we have this line that extends from the top of the circle here, which is at 0 and 8, to this x-intercept at 4. Okay, so the coordinate of this x-intercept, another way to write it, we could just write 4 and 0. So that's one line we're dealing with. And then we have another line that extends from a y-intercept of 4 to this rightmost point of the circle, right? This 8 and 0. So this point here, instead of writing 4, we could write it as 0 and 4. And then we have to find the area of the region bounded by the circle and then those two lines right there. Now, the way that I'm going to go about this is I'm actually going to find this area indirectly, because notice if we try to directly find this area, it's going to be really tough, because notice that it's kind of a weird shape that we don't have really a formula for. But what we can do is we can use these lines here and we can use these circles. So what we can do first is we can find the area of this quarter circle, which is going to be easy. It's just the area of the total circle divided by 4, right? So it's going to be the area of this entire quadrant here. And then what we could do is we can then subtract the area of these triangles that are formed. Notice that there's multiple triangles formed, and the two triangles that I'm going to use in particular is this triangle over here, right? Notice that's a right-angled triangle, and then this triangle over here. So one more time, I'm going to find the area of the quarter circle, and then I'm going to subtract the area of this triangle, and then the area of this triangle over here, and then the remaining area is going to be the area of the shaded region. So let's first find the area of the quarter circle. So the area of a circle in general is what? Pi r squared. So the quarter area of a circle is just going to be pi r squared divided by 4. And again, from the diagram, we could tell that the radius of this circle is 8. So if we plug that in, we'll have pi 8 squared over 4, which would give us, this would be 64. So we'll have 64 pi divided by 4, and then 64 divided by 4 would give us 16. So we'll have 16 pi, and because we need everything as an exact value, I'm going to leave it like this. I'm not going to get the decimal. Okay, so the area, let's keep track of what we're finding here. So the quarter circle area is equal to 16 pi. So one more time, that's the area of this entire region right there. And then what I'm going to do is I'm going to find the area first of this triangle. So let's label this. So let's say this is like triangle 1, right? And then I'm going to find the area of this triangle over here, which is going to be triangle 2. The triangle 1 area is going to be pretty easy to find because it's a right-angled triangle. If you remember, if you have a right-angled triangle like this, then it's easy to just make this the base, this the height, and then the area of a triangle in general is base times height divided by 2. But notice that the second triangle, it's not in this nice format. It's not a right triangle. And so we're going to have to do a little bit more work to find that area. But we'll get there. So let's first find the area of triangle 1, which is going to be the base. Notice the base, it has a length of 4, right? From 0 to this value, this x value of 4. So we know the base is 4. What's the height going to be? The height is going to be all of this right there, right? So from 0 to that y value of 8. So we're going to have 4 times 8 divided by 2, which would give us 32 over 2, which would give us 16. Okay, so the area, let's keep track of all these, of triangle 1 is going to be 16 units. Now let's talk about triangle number 2. This one's going to take a little bit more work. Notice that, let me draw that triangle over here just by itself. It looks like that, right? It's an obtuse triangle. There's an obtuse angle right there. How do we find the area of something like this, of a triangle like this? Well, there's multiple ways to do it, but what I'm going to do is I'm going to let this be the base over here, right? It's still going to be this formula, the area equals base times height divided by 2. The trick is getting the height. And the height, it's not going to be this line over here. Remember, the height has to be perpendicular to the base. And so what would happen is if we extend the base and draw an altitude from this vertex over here, that right there is going to be the height. Okay, so going to this diagram, the height is basically going to be from this vertex all the way vertically down to the x-axis. And so if you think about it, the height over here within this graph is going to be the y value of this point. Okay, because the y value, let's go back here, the y value of this right here, this is just the x-axis, right? So the y value is going to be 0 there. And then if we could find the y value of this point over here, right, we could find the coordinate of that point, then use the y value. Well, it's just going to be that y value minus 0. That's going to be the height that we could plug in. The base we already have. The base over here is just 4, right? From 4 to 8, from an x value of 4 to 8. We just need this height over here, and to get the height, we need the y value of that point. Question is, how can we get the y value of that point? Well, what we can do is we can find the equations of the two lines, because notice that this point here, it's the point of intersection between this line and then this line over here. So if we can find both equations of both of those lines and then find the point of intersection between those two lines, we'll have that y value that we need to find the height of that second triangle. So what I'm first going to do, this is going to take some steps here. I'm going to find the area of this line over here, and notice we have 2 points for it. So we got 0 and 8, and then we have 4 and 0. So we got x1, y1, and then over here we got x2, y2. Okay, so first I'm going to find the slope, which is going to be y2 minus y1. So we'll have 0 minus 8 over x2, 4 minus x1, which is 0. So we'll have negative 8 over 4, which would give us negative 2. Okay, so this line over here has a slope of negative 2. Notice that makes sense with the drawing as well. This is a negatively sloped line. So we'll have y equals negative 2x plus b. And then we could plug in either this point or this point to solve for the b value. And then notice that this is just the y-intercept. So the b value is just going to be 8. But if you want to show your work, let's we could plug in 8 for y, 0 for x, and we'd end up with b is equal to 8. But let's plug in this one just to do maybe a little bit more algebra, just to show you that it doesn't matter which one you plug in, you're going to get the same value. So this would end up being -8. Bring it over, we'll have 8 is equal to b. So the equation of this line over here, let's keep track of this. I'll write it over here. Y equals -2x plus 8. Okay, that's the equation of this line over here. Now let's find the equation of the second line of this line, and notice it has 2 points, 0 and 4, 8 and 0. So switching this up, we'll have 0 and 4, and then 8 and 0. So we've got to find the point of it, or the line that passes through those 2 points. So we'll have x1, y1, x2, y2. So first let's find the slope, which would be y2 minus y1 over x2 minus x1, which would give us -4/8, which would give us -1/2. So notice that makes sense as well. It's a negatively sloped line, and notice that it's less negatively sloped than this one. Okay, so that -2 is a larger negative value than this -1/2. So it makes sense in the drawing that we would get a smaller negative value if you look at it as an absolute value, like 1/2 versus 2, right? It makes sense that this one is going to be less negatively sloped than that one right there. So if you have a drawing like this, if you're doing your work, you could just check your work on the way and see if it makes sense with your drawing. So in this case, notice that the y-intercept is going to be 4. So we know the b value is it's just going to be 4, that y-intercept. If we plug in 0 and 4 over here, b would be 4. Or if we plug in 8 over here and then 0 for y, we'll have -1/2 times 8, which is -4. Bring the -4 over. We end up with that b value equaling 4. Okay, so the equation of that second line is -1/2x plus 4, like that. So we have the two lines, but what do we got to do now? Well, we have to find the point of intersection between them. Okay, so multiple ways to do it. What I'm going to do is I'm just going to let both of these equal, right? The y is isolated, the y is isolated, so I'm going to plug in this expression for this y. So we would end up with -1/2x plus 4 is equal to -2x plus 8. And from here, we just have an equation in terms of one variable. We could solve for the x value. So what I'm going to do, I'm going to bring the 4 over. I'm going to bring the -2x over. So that will become +2x. Then we'll have 8 minus 4, which would be just 4 over here. And then what's -1/2 plus 2, which is like over 1, common denominator. Between 2 and 1 is 2, so multiply this by 2, multiply this by 2. -1/2 plus 4/2, which would give us 3/2, like that. So this here would end up equaling 3/2x. And I'm actually going to combine these into 1, put the 4/1, and then I'm just going to cross multiply. So 3x times 1 is 3x, 2 times 4 is 8. X would end up equaling 8/3, like that. Okay, so the x value of this point over here, that point of intersection, is 8/3. But we don't want the x value. Remember, we want the y value. The y value is the one that's going to give us that height of that second triangle. And so what we could do is we could take this x value, we could either plug it in here or in there. It's going to give us the same y value. I'm going to plug it into the first one. So we'll have y equals -2x plus 8. So y would be -2 times that x value of 8/3 that we got. So this will be plus 8. So this would be, what, -16/3 plus this 8 is over 1. Now, common denominator between 3 and 1 is 3. So multiply this by 3, multiply this by 3. So we'll have 24 over 3. Negative 16 plus 24 is 8. So actually, in this case, the x value and the y value are the same. That's not always going to happen. In this particular case, it did happen. So this point here, it has a coordinate 8 over 3 and 8 over 3. And so the y value, remember, it's the height of that triangle. So the height of the triangle is 8 over 3. And so now we could finally find the area of that second triangle. So we'll have the area of triangle 2. We're still using base times height divided by 2. Now the base, as we mentioned, is just this. It's just going to be 4. The height is going to be 8 over 3. And then we're going to be dividing that by 2. And then from here, 4 divided by 2 is just 2. So let's simplify that. So we'll have 2 times 8 over 3, which would give us 16 over 3, right? This is going to be like over 1. 2 times 8 is 16. 1 times 3 is 3. So the area of triangle 2 is 16 over 3. The area of this triangle over here is 16 over 3. And now we have enough information to calculate the area of the shaded region, right? What are the steps? It's going to be the area of the quarter circle, which is 16 pi. So let's write this, the area of the shaded region. It's going to be the area of the quarter circle, which is 16 pi, minus the area of triangle 1, which we calculated was just 16, minus the area of triangle 2, which is 16 over 3, like that. And then from here, there's multiple ways to do this, to simplify this. Notice that this here has this pi attached to it. So it's hard to do 16 pi minus 16, but these two we can net out, right? So let's actually net those out on the side. So we'll have negative 16 minus 16 over 3. What do those net out to? Well, this is going to be like over 1. Multiply this by 3, multiply this by 3 for a common denominator. So we'd end up with negative 48, right? Yeah, over 3 minus 16 over 3. Just give me a sec here. Yeah, it looks all good to me. And so this would end up equaling negative 64 over 3. And then negative 64 over 3 does not simplify. So these two net out to that. And so one way that you can show this is just 16 pi minus 64 over 3, like that. Okay, and then if you wanted to maybe combine this into like one fraction, you could put this over 1, multiply this by 3, multiply this by 3. So you could have like 48 pi minus 64, and that's going to be all over 3. Okay, so let's erase that. This and this, they're the same thing. If you plug them both into your calculator, you'd get the same decimal. But I feel like this here is a nicer format. Okay, so that right there ends up being the area of the shaded region as an exact value.